Welcome back, students. 6.2. And now, now that we've talked about what rational numbers are, how we can put them in order, how we can change the way they look using FLOF, the fundamental law of fractions, so that we can rewrite them in a way that makes more sense to us at times, we're going to see what we can do to actually add the values together. Now, again, I think it's best to think about all of addition being the same. So when you think about addition, addition is really like combining like objects. Combining like objects. So what does this mean? For example, if you had -3 plus -2, if you think about this, you could really say that this is like 3 negatives plus 2 negatives. And because these are the same, you just end up adding the like objects and you get 5 negatives. It can be that quick. So when we get to fractions, if we have 3/5 plus 1/5, then those are like objects, and we could just add and combine the numbers like normal. We would get 4/5. Now that's using words, but there's no reason why it won't look exactly the same conceptually. Okay. The denominator is describing a denomination or a type. What are we talking about? And if those are the same, then addition will be very quick conceptually. So that shouldn't be an issue as you go through this section. Okay, now where do we get into trouble? We get into trouble when we have objects that are not the same. If we were dealing with chapter 5 and we had 3 negatives plus 2 positives, now those are not like objects. Then we would have to maybe take the -3 and break it up to decompose it into 1 negative plus 2 negatives. And then we could rewrite, but not using addition necessarily. Here we'd be using the additive inverse property. And that's how we can get to a value there. Now, you could also think of it as the chip model. Put in 2 positives. 2 positives with 2 negatives gives me 0 pairs. A lot of ways you can think about these. But again, if they're not like objects, we have to pause. We have to do something different when we have things that are not like objects. And that's what we're going to see here when we have 3/4 and we're trying to add that to 2/5. Those are not like objects. We should not say that this is 5/9 because we need to be able to add things that match with like objects. And ninths aren't anything to do with fifths or fourths or really connected to these whatsoever. So be really careful. Do not do this. As a matter of fact, in 6.1, we got to see that if you do this, where you add things together, tops and bottoms, you get a fraction between them. And that is not the idea of addition, right? Can you imagine 2 plus 3 and you get a number between 2 and 3? No, we're supposed to get something that would be larger than as we go forward because we're adding 2 positives together. All right. So anyway, that's the first little piece I want to talk about. That's the concept. We want things to be like objects. If we have like objects, things are going to be quicker. So they're going to show a couple different approaches, 2 different models, a number line model and an area model. And each one has its own kind of differences. The first one they do with circles, not a fan personally, and I mentioned that before. There's nothing wrong with it. They're just very hard to draw. So if they're already drawn for you, that's perfect. If they're not drawn for you, then try the area model that looks more like rectangles. Okay. Now just remember, with rectangles, you have to think about what is my whole unit, 1 unit or one whole object. Because you're taking 3/5, we need that to be a fraction of. So there you go. Number line wise, what you would do with again, this is all with denominators that are the same, is you would break all of things up into the denominators that you already have, and then you just go forward and count like we would before. So 2/5, I'd move forward, adding 1/5, continue. Very quick. Very quick and easy when you have the same denominator. The end result, though, isn't, it shouldn't be too bad here. Like for this one, 3/5 plus 4/5, we're not going to get tenths as the denominator because we're only talking about fifths. We just now have 7 of them. Okay. So picture that. Again, it's really easy for people to think, oh, I add the numerators, then I have to add the denominators. No, the denominator is just the type of object. So if you need to, think of it as 3 of these things plus 4 of these things is equal to 7 of those things. The things just happen to be fifths or 1/5. And the other piece to think about is when you recognize in the image that you have made one whole unit's worth and you have some remaining pieces, this is another way you could write this would be 1 with 2. Oops, lost my pen there. Give me 1 second. 1. Okay. Computer's freaking out. Oh, Microsoft Windows is not responding. I guess, can I cancel?